Hello everyone, we are group number 1. Our project title is Credit Card Default Prediction Model. Let me start by giving you all a brief introduction. Different people have different lifestyles based on age, gender, marital status, standard of living, cultural differences, etc. It is important to understand the causal relationship between these factors and the amount of money spent by people, since it would give us a good understanding of the marginal propensity to consume and how it changes with the factors mentioned above. This can bring about a revolution in our thinking and a measurement of poverty. Furthermore, establishing and analyzing the causal effect on the amount of money spent by people would help the government in the development of several areas of public policy making, such as the Patient Protection and Affordable Care Act introduced in 2010. There has been a lot of discussion prevailing on the efficient allocation of subsidies under this act. Nowadays, people usually use credit cards for everyday spending, and the rate of misuse of credit cards is increasing at a significant rate. The financial institutions and banks must know the background of the customer, credible or not credible clients, and then decide the credit limit for a particular customer. This research aimed at the case of customer default payments in Taiwan and compares the predictive accuracy of probability of default. From the perspective of risk management, the result of predictive accuracy of the estimated probability of default will be more valuable. This leads to our research question. How does a person's age, marital status, credit limit, past payments, and bill amounts affect the chances of having a default payment? The dataset that we will be using throughout the research project, the Default of Credit Card Clients dataset. This dataset contains a random sample of the credit card bill amounts, payments, and credit limit of the people of Taiwan. It also contains information on people's age, marital status, gender, and whether the person is a defaulter. I selected this dataset from the machine learning repository provided by the University of California, Irvine. There are 30,000 observations and 24 variables. So we started by cleaning the data first. For data cleaning, we performed the following steps. Got rid of extra spaces, selected and treated all blank cells, converted numbers stored as text into numbers, removed duplicates, highlighted errors, changed text to lower, upper, proper case, spell checked, and deleted all formatting. Some of the cleaning was done in Excel and the rest in R. We first started with basic summary statistics to understand the mean, median, standard deviation of the variables, and then plotted a histogram to understand the distribution. Next, to avoid multicollinearity effects, we looked at the correlation between different variables, and there were no multicollinear effects, i.e. no variable was highly correlated with another. The next step is analysis. For analysis, we use decision trees and logistic regression, as the problem is a classification problem. We divided the dataset into training and validation. Then we looked at the decision tree for the training set and interpreted that the repayment status in September 2005 is of the most importance, as the decision tree split on that variable. The next important variables are payment amount, billing amount, education, apart from other variations of pay. We then looked at the confusion matrix to differentiate between true positives, false negatives, and true negatives. A true positive is an outcome where the model correctly predicts the positive class. Similarly, a true negative is an outcome where the model correctly predicts the negative class. A false positive is an outcome where the model incorrectly predicts the positive class, and a false negative is an outcome where the model incorrectly predicts the negative class. So in our case, the decision tree predicted the positive class correctly for 11,095 and negative class correctly for 1,253 data points. We performed the same on validation set. The accuracy of both training and test was around 82%. After this, we based our analysis on logistic regression. The betas in logistic regression are interpreted quite differently than the normal regression model, and the concept of probability to log of odds is used here. So everything starts with the concept of probability. Let's say that the probability of success of some event is 0.8. Then the probability of failure is 1 minus 0.8, which is 0.2. The odds of success are defined as the ratio of the probability of success over the probability of failure. In our example, the odds of success are 0.8 over 0.2, which equals 4. This is to say that the odds of success are 4 to 1. If the probability of success is 0.5, i.e. 50-50% chance, then the odds of success are 1 to 1. The transformation from probability to odds is a monotonic transformation, meaning the odds increase as the probability increases, or vice versa. Probability ranges from 0 and 1. Odds range from 0 and positive infinity. The transformation from odds to log of odds is the log transformation. Again, this is a monotonic transformation. That is to say, the greater the odds, the greater the log of odds, and vice versa. Why do we take all the trouble doing the transformation from probability to log odds? One reason is that it is usually difficult to model a variable which has restricted range, such as probability. This transformation is an attempt to get around the restricted range problem. The model says that holding other variables constant, the odds of default payment next month for increase in age by 1 is equal to 1.0707. All the remaining variables can be interpreted like that. After that, we looked at the confusion matrix like decision trees, and the model predicted 11,584 correctly and 290 as negative classes. Lastly, we plotted the receiver operation characteristic curves. It is one of the most important evaluation metrics for checking any classification model's performance at various threshold settings. AUC represents degree or measure of separability. When we decrease the threshold, we get more positive values, thus it increases the sensitivity and decreases the specificity. Sensitivity, the true positive rate, and the specificity is the true negative rate. Similarly, when we increase the threshold, we get more negative values, thus we get higher specificity and lower sensitivity. Alright, next are the data visualizations. The following visualizations were done using the data in Tableau. So first up is the default rate by limit balance. As you can see in this chart, there are 3,593 people with 50,000 credit card limit balance, and that did not default in the past 6 months. And in the same group, there was 1,328 people who did default in the past 6 months, which is the highest number for the default rate. Next is the default rate by sex. As we can see in this picture, almost 48% of women didn't default on the credit card in that period, but women also had the highest number for the default rate. Next is the default rate by education. In this picture, we can see that those people with college degrees have both the highest rate for the rate of default and not defaulting. Default rate by age. In this picture, 18% of people between the age 25 and 30 years old did not default on their credit card, which is the highest rate for not defaulting. However, almost 5% of people in the same age range had the highest default credit card rate in the past 6 months. The pie chart shows that most of the people are either single or married, and only about 2% make other categories. Next, we wanted to see if age plays any role in the relationship status. In the age of 20 to 30, most of them are single, and other than that, all other age groups have more married people. Next, the relation with default payment shows that single and married people are more responsible compared to others. Billing amount by age. The people in age group 30 to 40 spend more, followed by people in ages 20 to 30 group. For the payment status in September 2005, 77% of people paid duly, 12% paid a month later, and about 9% paid 2 months later. 76% of married people pay on time, and 78% of single people pay on time. More females pay on time compared to males. This is a visualization of what I just previously said. So the conclusion. Previous payments made by clients play an important role in determining the credibility of client and deciding the credit limit. Married people are more responsible and should be given higher credit limits. Billing amount relates to the payment status of client, i.e. when amount is in limits, then they pay duly. People in age group of 30 to 40 spend a lot of money, so these people should be targeted for increased revenues.